Okay, Year 12s, welcome to anti-differentiation or integration. What we're going to look at now is the opposite of differentiation. So just to start things off, say we've got x to the power of 2. We differentiate that, that becomes 2x. We're going to look at how we can make this 2x become x squared again. So let's just delete all that stuff and let's have a look at some stuff. So basically, if we've got x to the power of something and we're anti-differentiating it, that power goes up by 1 and we divide by the new power. So if we've got a 2, we go up by 1, and then we put that, whatever we end up with here goes at the bottom as well. If we've got a constant multiplying x, we can bring that constant out the front of the integration symbol, and we just anti-differentiate like normal. And then that a, the constant, follows it through. If we are anti-differentiating and we've got a plus between two functions of x, we can break that up into two separate integrations or anti-differentiations just to make things easier for ourselves. Following on from that, if we've got something that looks like this, we've got a set of brackets. Kind of like with the chain rule, rather than going off and expanding, we don't actually have to expand. We can apply this rule, which tells us that if we've got to the, some function of x to the power of n, all we do is we add 1 to n, so it's n plus 1. It's a bit of a dodgy looking plus, but that's what I've drawn. So it's n plus 1 with our function over a, so whatever we've got our coefficient of x, times by n plus 1. So whatever we've ended up with there. Okay, let's look at how this works. So for the first couple of examples here, we're going to use this property here, and we're going to might have a look at this one down here. We'll actually have a look at all three. So to kick things off, x squared. So we've got our power, we've got a power of 2, so therefore that's going to become x to the power of 2 plus 1, which is 3, over 2 plus 1, which is also 3. Now one thing we've got to do, and I forgot to put it here in the example, or in the formula, is to put this plus c. The reason for the plus c is that we're adding a constant. Going back to our example of x squared differentiating to 2x, we could have x squared plus 5. That'll also differentiate to 2x. Or we could have x squared minus 3. That'll also differentiate to 2x. As a result of that, our constant can be an infinite number of things. So all we do is we put this plus c in here to remind ourselves that we're going to have a constant there being added. Okay, and get rid of some of this other stuff here, and we'll go to work on the next one. Okay, so here we're having a look at, we're anti-differentiating 3 over root x minus 4 x cubed plus 2 over 5 x cubed with respect to dx. Now, if we're doing this, we've got to make sure we've got all of our powers written in positive. Make sure our square is written as powers, and that'll allow us to go through it from there. So we can break this up as 3. Now once again, our constants come out the front, so this 3 can come out the front, and we've got x to the power of negative 1 over 2 dx. Now minus 4 x cubed dx plus 2 over 5 x to the negative 3 dx. And from there it makes this whole adding of powers a lot simpler to work with. So over here, now we're working with this line here. So we'll have 3, and we're going to have x to the power of positive a half, because we add 1 to it. We're going to put that over 1 over 2, minus, we've got our 4, x to the power of 4 over 4, because 3 goes up by 1, plus 2 over 5, x to the power of negative 2 over negative 2, because 3 plus 1 gives us negative 2, and that's got to go at the bottom as well. And remember, put in our constant of c. And from there, we simplify. So 3 divided by a half is 6, x to the power of a half, minus, the 4's will cancel, so we've got x to the power of 4, and then we've got 2 on 5 multiplying negative 2, So we've got negative 2 over 10x to the negative 2 plus c. And then once again we'll clean this up and we'll put it in the same form as we got it. So we'll have 6 times the square root of x minus x to the power of 4, and we've got minus 1 over 5x squared plus c. So they're the steps we take to differentiate, and it's just the start of differentiation.